The name of this talk is Dissecting Kotlin, and actually if you were at DevFest a few months ago, I did a very similar talk called Dissecting the stdlib, where I basically talked really fast and ran through a laundry list of some of my favorite things in Kotlin. And this talk is going to be not quite like that, and in a way this talk, which is I guess you can call part of a series because now there's two of them, is kind of a mirror of like my own journey through Kotlin. And so like when you first learn Kotlin, there's like all these language features and you get really excited and you want to use them all. And then a year down the line you kind of think, okay, well maybe I might use this differently, or I might use that differently, or I might think about things a little bit differently as you kind of learn what the features are and you kind of use them in your day-to-day life and you kind of figure out what works for you and what doesn't. And this is kind of what this talk is like. So rather than going through a whole laundry list of features and talking really fast through all of them, I'm going to talk really fast through just a couple of features. And really the goal here is, I have this question that I keep trying to answer for myself as I'm kind of learning Kotlin. I think I started Kotlin like November 2016. It's like almost 3 years later, and I'm still having to try to answer this question: what is idiomatic Kotlin? And if you look up, the word idiomatic as it applies to, programming and computer science, you kind of get definitions that are like, oh, it's native, it's like code that's native to a language, or it's natural code to a language, or it's code that follows the conventions of a language, which, okay, fine, so that kind of makes sense, but what does that mean for Kotlin? And I still find myself trying to answer this every day, and in the context of, am I writing good Kotlin code? And so rather than trying to learn everything about every feature that I could about Kotlin, I said, okay, well, let's kind of back up a little bit. And I kind of got inspired by the keynote from Kotlin Conf last year in 2018. And Andrei Breslov, while kind of after talking about all the amazing kind of adoption stories about Kotlin, kind of talked about, kind of similar to what Christina talked about this morning, about kind of like some of the philosophy and the ideas behind the Kotlin team. And he talked about that P word, pragmatic, and he kind of tried to explore what that meant for the Kotlin team. And I would definitely just go and watch the keynote. It's really cool. It's really fascinating to kind of understand like their thinking behind it. And in the keynote, just to kind of review a little bit, he said that the main goal of the Kotlin team is to create a pragmatic language. And what does that actually mean? Well, they want to write a language that helps you get things done. And there's this really cool phrase that he kind of said about, they wanted to write a language where you could turn your thoughts into working software without any hoops to jump through. And that's really cool. And he goes on further to talk about, what does pragmatic mean for the team? And the part that really blew my mind is that he basically went through this list of things that people kind of compliment Kotlin on. And he says, he kind of almost like basically, not necessarily contradicts, but says that, these are great things, but there are things that the team kind of focuses on or prefers to kind of focus on in terms of like what their goals are and what they're trying to do with Kotlin. And you notice the very first one on this list is concision. And it's really funny because I hear, I know Christina talked this morning, had a great talk about, basically the tension between the different goals of Kotlin, and conciseness is one of them. And you see the word concise everywhere in the Kotlin documentation, in their books. But you notice it's crossed out here on the left side. And what Andrei says is that, okay, conciseness is a great thing, but really what they care about is readability, which I don't necessarily see as contradicting conciseness, but more a kind of be more specific about what they're trying to aim for. And if you've ever been kind of working with someone who loves to code golf and write as brief code as possible, you know that there is a point where concise code becomes unreadable. So conciseness is important towards readability, but the idea that code is understandable, that it is more maintainable and readable, is kind of more the idea behind conciseness rather than just kind of make code as short as we possibly can. Another thing that Andrei talked about that people laud Kotlin for is expressiveness, being able to kind of write really cool and interesting things, be able to express business logic in really interesting ways. And he said that's really great, but one thing that they actually prefer over expressiveness is reuse, being able to write reusable code that can be used in different parts of your app without having to write things over again. Like, it's really great if you have a language that has all these features that allow you to express things in a very interesting way, but it's more important that you give people the mechanism to reuse code. And he talks about how people think that, or kind of compliment Kotlin on being very original. There's some really interesting features in there. But that really, while that's great, what they care most about is interoperability. And I know that I was on a team that was, I'm on an Android team, Android developer, and so we had this huge Java code base. And part of us being able to adopt Kotlin was the interoperability, that focus on being able to use Kotlin even though we might have thousands and thousands of lines of Java, and being able to shift gradually and at our pace to this new awesome programming language. And he talks about something called soundness, which for me is pretty academic, and I kind of get it. It's a little over my head, but it has to do with like the compiler and when it's like telling you one thing versus telling you another thing. But anyway, Andre says that rather than worrying about kind of soundiness or soundness of the language, they care a lot about safety and tooling, which are things that Christina talked a lot about this morning. But I think especially like the first 2 or 3 things were kind of really blew my mind, because I know that when I talk to people about Kotlin, I was like, oh, it's like so concise and it's so expressive. And I would say this at talks. And so sitting there hearing Andre Breslov say that, well, we really care more about readability and reuse, kind of made me rethink about how I approach Kotlin. And that the features in Kotlin are really cool, and of course, using Kotlin features kind of in a broad kind of experienced way is probably part of being idiomatic. But maybe part of being idiomatic is also kind of keeping the thoughts of the people writing it in your mind and seeing how that can influence not just the way that Kotlin is written and the way that features work, but also the way that you can look at Kotlin, how you can use Kotlin, and how you can write your own kind of Kotlin-based kind of tools and utilities and features, and keeping that in mind. And maybe that has something to do with being idiomatic as well. And that's kind of what I've been thinking about. And so rather than kind of, again, going through a whole laundry list of my favorite Kotlin features, I wanted to talk about kind of this mechanism in Kotlin that really fascinates me, and that I think really spoke to a lot of things that Andre talked about. And this is this idea of conventions. So conventions in Kotlin is this kind of mechanism where you can access certain language features and constructs by giving a feature, or giving a function rather, a certain name. So rather than having something tied to you implementing an interface or you subclassing a certain class, you can just give something a particular name, and that unlocks like all these really cool and sexy features. Now, if you're a person from Java world like me, you might recognize certain language features that are accessible through, subclassing particular classes or implementing certain interfaces. So something like try with resources. So if you've ever had to do anything with I/O, you know that in Java, a lot of times you'll have to create a stream, open the stream, do all this thing on the input or output, and then you have to do all this rigmarole of making sure you close the stream. But if there's an exception when you close the stream, then you have to do some other stuff and some other error handling, and then make sure that you finally close everything. There's a lot of rigmarole, right? And in Java, there's now this construct called try with resources, where basically if you are using a class that implements auto-closable, it'll take care of all that for you, right? It'll do like the opening and closing and all that error handling for you, and that's try with resources. Now, it's a really great tool, but again, it's tied to classes that are auto-closable. And there are kind of other things in Java that you unlock basically by implementing certain interfaces. So if you're familiar with this really nice for syntax, where rather than having to create iterators or mess with indices, you can use really cool for syntax where you go for and you have your little variable, and it iterates through a collection of some sort. And it's pretty readable, right? It's pretty simple. And this is a really cool and nice syntax, but again, it's tied to a particular interface, to iterable. And there's nothing necessarily wrong with that, but it does tie you down, right? If you say want to add iterability to a class that you own, you have to own it, or you have to subclass. If it's a class that you don't own, you have to subclass it. So there are some strings tied to some of these language features. And Kotlin has some of these features. They have this really nice for syntax, which is also from iterable. But what's really nice about Kotlin is that it does not tie you down with the strings as hard. It does provide you some of these really nice syntaxes, some of these really nice features, but you just have to give the right function name, and usually a little bit of a modifier keyword, and you can get the same kind of functionality. Now, side note, if you've been doing Kotlin for a while and you've had to do any input-output, you know that try with resources, while it is in Java and is really awesome, does not exist in Kotlin. And kind of as a really good example about why it's hard to be tied down to getting features through interfaces and classes, is try with resources. So Kotlin is compatible down to Java 6, and try with resources requires auto-closable. autoclosable wasn't introduced until Java 7, which is why we don't have try with resources kind of more in a very specific Kotlin implementation. But in case you were wondering, there is a extension that allows you to kind of abstract away some of that like stream management, and it's called use. But again, this is why it's so important and why it's so cool in Kotlin that we have this idea of conventions, of features being opened by names rather than by classes and interfaces, is that it gives you some freedom to, you know, be able to play with some of this functionality and have it kind of open to you. And what I really think is cool is that it ties in, like, I don't know if you've been doing Kotlin for a while. I feel like I ask, whenever you ask someone what their favorite Kotlin features, I'd say like 2 out of 3 times someone says extensions. And extension functions, if you're not familiar, is this way of adding functionality to, again, classes that you may not own, or that might be written in Java, or that are in a library somewhere, but you can add functionality, you can add utility to it without having to be tied down to owning it or subclassing it. And it's all based on this idea of, you know, like it goes again to this idea of kind of writing code that works without any hoops. And I think that's what's really cool about conventions, this idea of kind of untying those hoops. And so the first feature that I want to talk about that I really love is operator overloading. So I actually come from before Java. I came from a C++ background, and I remember moving to Java and really, really missing operator overloading. If you're not familiar, and you go to Wikipedia, Wikipedia defines operator overloading as operator ad hoc polymorphism. But really what it is just syntactic sugar. It's this idea that you can take symbols in the language, like the plus equals, and give it custom functionality, right? You can use those symbols with your own classes. And again, it feels so familiar, right? Like this extension function is one of those things that I feel like I know was my first love in Kotlin. And again, this idea of, okay, I don't own the class, I don't have to subclass anything, but I can use, you know, this beautiful syntax, these lovely features, and just add onto it without having those strings. And again, this also ties into kind of the Java interop story as well. Now, in Java, there's not operator overloading. Like the smallest hint of a whiff of operator overloading that you might find in Java is using the plus for string concatenation. But, you know, in Kotlin, there is operator overloading. Now, one of my other first loves in Kotlin was the many extension functions in the collections API. And you know, in Kotlin, if you look at the kind of collection center lib, it adds all these like lovely functions that allow you to write really fluent, you know, lovely code, things like filter and filter not, and it allows you to like kind of write things like this, where you can write some really complex logic, but in a very fluent, readable way. And Kotlin doesn't just have these kind of collections operators, it also has operator overloading. So it's not just that I can just filter lists and plus them together, I can also use things like the plus assign operator. So this is all from the Kotlin standard library. So say that I'm off on a voyage of discovery on a spaceship, boldly going where people have never gone before, and I want to put together my crew. Now, if I was kind of just using the Kotlin standard library to do that, I might do something like this, where I have a bunch of crew members, and I might have a function that puts together a mutable list of crew members. And because I have the Kotlin standard library, and because I have operator overloading, I can do it like this, where I have a mutable list, and rather than calling, you know, the add method, I can go ahead and actually use the plus assign operator and add them together like this. And if I actually run this code, and if I just say iterate through that crew and print out their names and run it, we can see that, okay, all right, I was able to compile a list of crew members and print out their names, and I was able to do it using kind of symbols and operators that we generally associate, you know, with primitives, but we can use it with collections because of operator overloading. Now, it's not just that I have these things in the standard library. I can also add operator overloading to my own classes. So say rather than having just a simple list of crew members, I wanted to write my own ship class. I wanted to create an abstraction for my ship and all the things about it. So I might go here. And this is a really simple class, but rather than just having a simple list of crew members, I might have a name, I might have the class of my vessel, and here I have a very simple crew property that is backed by mutable list. All right, so that's cool, but well, what else can we do with this? So let's try to jazz up this a little bit and add some kind of nice syntax to our ship. So Kotlin still has the iterable interface. So if I wanted to do that really cool for syntax, I could do something like this, where I have my ship, implement the iterable interface, and then the thing I really need is to implement the iterator, and I'm going to cheat, and I'm just going to return the iterator that comes from my crew list, and that's it. Now, rather than now playing with a list of crew members, if I wanted to have, say, something like this. So now I have a ship object, not just a simple list of crew members. And it does have a list of crew members in it, but rather than iterating through that list directly, I can do something like this, where now I have that really nice for syntax, and I can directly kind of more directly iterate through that ship, and not just the list of the ship, but iterate almost on the ship directly. And it'll look something like this, where I iterate through, print out all the names, and it looks like that. Cool. All right, that's pretty nice. But you know, I'm trying to talk about operator overloading, and I just implemented an interface. Well, what's really cool is how operator overloading works on Kotlin. So rather than having something like this, let's take a different tack, and let's add the plus equals operator to my ship. So the way that operator overloading works on Kotlin is that you start off with this operator keyword. So you're letting the compiler know, hey, I want to overload an operator. You'll type fun, and what's really cool is if you hit autocomplete, you get a list of names. So I mentioned that conventions are basically Kotlin providing you with language features and constructs if you give a function the right name. So in terms of the operators that you can overload, if you just type operator fun and hit the autocomplete, you get this list of function names. And you can see it's a little bit light, but on the right are the actual kind of symbols, the language symbols that these function names are associated with. So if you implement a function with this name, give it the right signature, you can use the operators on the right on your own classes. So if I do, say, plus assign, and say I want my plus assign to be like, okay, well, what if I want to give my ship a crew member and just have them add that crew member to the ship. So I type in crew member with a parameter, and then let's return unit. And then what I'll do is just delegate to the crew and add that crew member, something like that, okay? And that's it. Now if I go back here, now say I do something like this, and then run. So I've overloaded that operator, and now rather than calling crew.add, I can just do the plus assignment operator, and I've added a fourth crew member to my crew. It's pretty cool. And we can do some other things. A couple of things to note, though, is that there is a limited set of operators that you can overload, and it gets a little weird, the rules. So if I had tried to, say, add a return type to my plus assign, I'll get a compiler error. And it really depends on which method you're talking about, but there are kind of restrictions on like the return type and then parameters. So just to be something to be aware of. But let's try to add a few more things. We can do something like a minus assign. And let's try to get rid of this interface, right? So I'm talking about kind of removing the hoops. So I don't actually need the iterable interface to have like that cool iterator syntax on my ship. I can remove that and then just switch out the override for the operator keyword. And if I go back, it still compiles, and let's say, oops, something happened while everyone was on a away mission, and that poor crew member that was unfortunately wearing a red shirt, something happens to them. They didn't make it back, and then we do something like this, and we want to see who is still on the ship. And go ahead and run that, and cat go. And okay, pull this up a little bit, and we can see, okay, so we've added a crew member. We've unfortunately had to take them away, and without any interfaces at all, we were able to kind of utilize that really nice for loop syntax. And there's just so many things that you can do with this, with operator overloading in Kotlin. There's just so many different operators. Say like I wanted to be able to use in. So if I had, say, a function that was called contains, and it returns a Boolean, I can test whether a certain crew member is on my ship. I can actually use square brackets to kind of access my crew members. So if I want to do something like that, it might look like, oops, like this. So there's actually a couple different ways you can actually override the square bracket. You can use it like an indexer. like an index, so I can actually say, okay, if I give you some zero-based index, pull out the crew member in the list of that index. I can also use square brackets like I would with a map, where I actually, instead of giving it index, I can give it some kind of key value, and I can have some kind of logic that maps that key value to, say, a crew member, like say by their name. And so if I do something like that and go back in, and let's do this instead. So I can do something like this, and I can also do something like this. So rather than going ahead and kind of writing out really a little more verbose code, I can do something like this. I can use the square brackets as an index. I can use square bracket as kind of like a map syntax, and I can use in to test whether my crew member is in my ship. And just to prove to you that it works, and yeah. And as you can see, I pulled out my second crew member, who's my idiomatic science officer, and I tested whether my tech sergeant is in the house, which unfortunately he is not. So there's a lot that's pretty cool, and there's a lot of things that you can play with and experiment with in terms of doing operator overloading. Now, something you might notice is that all of these operator methods that I just implemented are member functions, so they live inside of my ship. So you're not restricted, though, to just creating operator overloads as class methods. You can actually create operator overloads as extension functions. And you can actually do it really easily from here. Say you kind of wrote this as a member function, and you felt like more you wanted to do it as an extension. There's actually a context action where you can convert member to extension, and it'll actually move it outside for you. And there are compiler errors, which I'll get to in just a second. So kind of going back again to this idea that we don't want to necessarily always be tied down to interfaces and subclassing, or say we wanted to kind of jazz up a class that we don't own. We can still leverage operator overloading, but just through extension methods. Now the proviso is that if it's an extension method, you won't get access to the private members of that class. But luckily for me, there's a public getter for the crew. So I can go ahead and still have my operator overloading and have them work just fine, even as extension methods. So I think that's just really cool. And again, it's this idea of not tying things down and just using names to access these really cool features. Now, how does this all work under the hood? Is there any magic that is transforming this code into kind of some kind of Kotlin secret sauce? To answer that, we're going to take what I like to call a bytecode break, and I'm going to show you how the operator overloads actually look in the kind of compiled Java code. So just to show you that. This is basically the same example, just here in a separate file. And I've got my in operator, my plus equals operator. And if I open up the Kotlin bytecode and scroll down, you can see that for syntax is really just an iterator. And when you see that plus a sign, when you see that in, it's really just calling into those functions that you wrote. And this one's a member function, so it's being called in the instance. This one's a static function, so it's being called like a static function. And that's it. All of the operator overloading, it doesn't change the inherent performance or anything about the code. It's just really nice syntax to make it more readable, more understandable, and to help you add meaning to your abstractions. So, but what's really cool is that because of some of this flexibility, you can do some really neat things. Now, I know if you're in Java world and you move into Kotlin, there's always questions about how do you kind of start moving things over? Like how can I make sure that my new code that I write in Kotlin works with my old code? Do I have to write the same function if say I get some new business logic? Do I have to write it in Java and in Kotlin so that it works in both places? No. And in fact, you can go ahead and write your really cool operator overloads, especially as extensions, and be able to use them in Java. And I know that in different projects I've been on, that's a really good way of, again, introducing new Kotlin code and being able to make sure that your business logic is in one place and you don't have to fix it twice over, and be able to, again, use the cool, sexy features in Kotlin, but still have that utility and still be able to kind of keep things sane in your Java code. So say I had those extension methods on my ship class. Now say I have some Java code sitting in a corner, very sad and alone. I want to go visit it, and I want to kind of do some things with my Java code. I can still use, again, my Kotlin ship class within Java, but I can also use my operator overloads. I don't get to I don't get the as nice syntax of the operator overloading, but I do get to do something like this, where because I wrote that contains method that maps to that in operator as an extension function, I can call on that extension function as the kind of underlying Java, static function that it is, and use it in Java. So that's just something that you can do if you're still living in a kind of partly Java, partly Kotlin world. But it's not just Kotlin necessarily that can have the fun. If you say have a class written in Java or a class tucked away in a library somewhere and you want to add operator overloading to it, you totally can. So say I had a different ship. It lives in the universe where only Java exists. So it's written in Java. This is basically the same class that I had before. It has a name, it has a vessel class, and it has a list of crew members. And say that, I have to get on this ship. It's the only ship around. It's a piece of junk, but I got to make do. And I'm in this Java universe, but I want to add a little bit of operator overloading to it just to make my life a little bit easier. Well, I can totally do that. I brought my Java ship over to Kotlin world, and I can actually, using extension methods, extension methods, I can go ahead and add operators, overload operators to my Java ship, and then I can go ahead and do things like this, where I have a comparison operator, I have my plus assign, and again, it's all along these kind of like really cool, kind of recurring themes that we see in Kotlin about adding functionality without having to implement interfaces or override classes, and also not just that. It's kind of a cool way. Like extension methods aren't just a way for you to kind of add functionality, but even if you're just writing your own class and you have this beautiful class, it's this pure, beautiful abstraction. It's got everything that it needs, but you still have like utilities that you want to add to it. You still have things that you want to do with this perfect little class. You don't always have to jam everything into that class, right? You can write extension functions for it. And you can kind of see, again, with operator overloading in the same way with extensions, they're just ways of kind of separating out, kind of like the nitty-gritty things you have to do with it from your beautiful, lovely abstraction. And I think, again, that's also applicable to things that might live in Java world. So there are some provisos, though, and it's really interesting. If you kind of look at the actual, operators that are available for operator overloading, it's kind of a small subset, and there are certain things that you have to be careful of. There's actually, if you're new to Kotlin, there's a really great Coursera course that is taught by, this is really tiny, but it's taught by Svetlana Isakova and Andrei Breslov. It's on Coursera. It's actually really cool, and it's Kotlin for Java developers. But they have some really great videos where they kind of talk about not just the features itself, but the wheres and whys. And there's actually a very specific section, very relevant to this, where the question is asked of Andrei Breslov, can you give some use cases when to use and when not to use operator overloading? So you might get frustrated sometimes when you look at the operator overloading list and be like, well, why isn't there more? Or why can't I do more with this? And you've actually watched the video. Andre says very explicitly that being able to do this kind of custom code, because these kind of custom behaviors with operators, is really powerful. And with great power comes great responsibility. And that it kind of reflects back into, and Christina said this morning that the team and Andre in particular are very thoughtful about what they do with Kotlin, what they make available. And operator overloading is another kind of example of that thoughtfulness, and that's why it's so restrictive, is that operator overloading should enhance and make things more understandable, but with custom behavior like this, it's really easy to kind of obfuscate things and make things really complicated and make things really esoteric, and so that when the new member of your team comes on and sees your code, they're like, what the hell is this? And operator overloading is like that. And so kind of a caveat when you're working with operator overloading is to use it, but really think about what you're doing with it. It's kind of easy when you come to this new fun language and see all the features and just want to cram them all into your code. But it's really easy to kind of take it a little too far, and then you start veering away from readability. And Andre actually gives us a really great example in the course of, say, the slash operator, right? We know this as, a mathematical operator. It's division. And he said, well, I could see a case where, say, you have a path class, and you really want to use that slash operator as like a way of building paths. But even though that kind of makes sense to you, that's kind of counter to how we typically use that, right? So all of these symbols and stuff, you can do whatever you want with them, really, but the kind of goal is to keep things readable and reusable. And when you start kind of going, a little crazy, you start moving away from that. And so that's partly why the operator overloading is a bit restrictive, is to kind of kind of help us all kind of be better Kotlin people and not to go too crazy, but also this idea of focusing on using custom behavior where it's warranted, but trying to stay within the bounds of kind of commonly used, kind of common semantics that we have for these kind of things. And there's kind of other things. I'm actually running out of time, so I'm not going to go into it too much. But the compiler sometimes like tries to optimize certain things, so you have to be careful. There's a lot of documentation about not implementing all the operators as well, because there's certain things the compiler tries to do to help you out, which might kind of result in conflicting behavior. But the idea is that, and I think this is actually kind of like the overarching thing that kind of drove me to write this talk, is that, okay, my first going to Kotlin resulted in this talk where I was looking at all the shiny things and they're so wonderful, but a lot of times I think writing idiomatic Kotlin is taking a step back and really thinking about what you're doing. And again, kind of emulating that thoughtfulness of the Kotlin team in your own life. And I mean, it's not like you're gonna get it right the first time. I know I recently looked at code that I wrote like my first year at Kotlin and was like, what is that? What is this horrible thing? And it's always a process. And I think that, as we go forward, we're gonna make mistakes. We're gonna write code that we absolutely hate 6 months from now. But I think that trying to keep these things in mind, these ideas in mind, these kind of high level, pragmatism, readability, reusability, and then kind of seeing how they manifest in the features, and then trying to emulate that will kind of at least maybe put a few like bumpers to keep us out of the gutter sometimes. Sometimes they'll end up there, but help us out a little bit. Just to go through a few more things. Conventions are in quite a few places in Kotlin. If you've ever used destructuring declarations, those are really cool. So destructuring declarations are declarations in that they're declarations of vals and vars, and destructuring in that they allow you to take an object with a bunch of properties, tear it apart, and then take those pieces and stick them into the vals and vars, which sounds kind of horrifying now that I say it that way. But it's basically allowing you to kind of write a little more concise, a little more kind of easy to understand code. So I have a very simple example here. So on the right, this is actually, if you're not familiar with the syntax, it's actually a pair. So it's more looking like this. And if I didn't have destructuring declarations, I might write something like, I may be writing something like pair.first, pair.second, but with destructuring declarations, I can actually, in the same kind of line, both declare a val, give a name to it, and by the position that it is in this kind of like parentheses wrapped list, say, hey, this first val gets the first property, the second val gets the second property. And it's all based on just like the order in which you kind of define these value names. And there's some kind of more interesting examples. So say I had something like this. So fleet map is actually a map. So I have a bunch of ship objects, which is my fleet, and then I have this map where I'm mapping the name of the ship to the actual value of the ship. And if I wanted to kind of iterate through that map and maybe, I don't know, do something with each ship, I might write something like this, where I have my nice for syntax, and it goes through each entry in that hash map, and then to actually kind of access the values on each ship or the key itself, I might do something like entry.key, entry.value.vessel class. It's fine, it works, it's pretty okay, but it could be better. And it can be better with destructuring declarations. And there's actually a context action for this. So if you have kind of a situation where destructuring declarations are available, you can open up the context actions and use destructuring declarations. And then, rather than having to go into the entry and pull out the key and value myself, I get these nice little kind of inline in the for loop variables that pull out the key and pull out the value and make this just a little bit nicer to read. So I can actually add destruction declarations to my own classes. So if you find yourself, if you have some kind of object where you're constantly pulling out this thing and this thing and this thing, all the time, you can actually make it a little easier on yourself by using destruction declarations. So if I go to my ship class and say I wanted to just be able to very easily create values from these three properties, it's a little bit different than normal operator overloading. So it does use the operator keyword, although it's not exactly operator overloading. And if you kind of open up the autocomplete, you won't see anything related to this. But basically, for each for each, I guess, position that you want to be able to be kind of filled with a property from that object, you write a method, and it's going to be component, and then the number of the position of that property in which you want to extract it. And then for this one, say let's look, the first property that I want to extract would be the name. Let's say if I did the second one, it's just kind of going down the line, the vessel class. Okay, and then the third one, let's just go ahead and get those crew members out as well, because they need some shore leave. So something like this. And then, so what I can do is when I'm actually accessing that class later, rather than going through, and I have another main function here, let's get rid of that. Go back down here. So if I run this, so again, rather than having to go through, pull out each property myself, I can use this destructuring declaration to, in one line of code, declare the val and assign, different properties, the value of different properties on my ship to those vals. It's really easy to get mixed up with this, so you have to use it cautiously. If you do something like where you kind of reverse values or misorder them, the compiler will kind of be like, hey, excuse me, but it is there for you. It definitely is something that can be easily messed with, but it is an interesting it is an interesting feature of Kotlin. If you use data classes, which I know everyone loves data classes because it gives us things like equals and toString out of the box. I did not know this 6 months ago, but it also gives you this destructuring declarations out of the box. And to show you that, let's open something like this. All right, so I have a data class. It's a time machine, has a whole bunch of properties on it. And say for some reason I would want to use destructuring declarations on this. Well, to show you that you can, I'm going to take a quick bytecode break and show you that when you have a data class, regardless of how many silly properties you have on it, along with the equals and along with the toString and all the other nice things that you get a component function. Where are they? You get a component function for every single value that you declare on that data class. So that's something for you. I don't know if there is a limit to components. I thought there was, but in the interest of this talk, created a data class with a ton of values, and they all had component methods. So just to be aware of as well, if you, I guess, worry about code bloat or if things are getting silly, maybe that's a sign. But that is something that you get with data classes. Just something else to like about data classes. Let's see. How much time do I have left? Ooh, not much. So just really quick, a few more things that are based on conventions. One of the first things that I thought was really neat about Kotlin was the to operator. And I remember very well kind of Googling Kotlin to keyword and not coming up with anything. To is a very general word, so it's hard to Google anyway. But the reason another reason why I had a problem was that this is not actually an operator, it's an infix function. So basically infix is yet another kind of Kotlin feature that you get through conventions. So basically, if you have a method that meets certain, or a function that meets certain criteria. If it's single parameter, no var args and no default args, if you throw an infix notation on it, you can actually call that function without dots or parentheses. And so if you've ever used methods like down to, if you're like me and you like shift in the bits, and the shift right, those are all infix functions. And unsurprisingly, you can actually use infix to create your own binary operators. And say I had something like, say my crew members, say I didn't really like the plus equals and minus equals. I feel like it's not really, like I don't find it as readable. Rather than say plus minusing or plus equaling and minus equaling, I just turn those into verbs, members onto my ship, I could actually write infix functions. So say I did something like this. So rather than actually adding them and subtracting them from the ship, say that I want to just assign crew members and transfer them between ships. I might write something like this and something like this, and to actually see what that looks like. All right, so I have a couple of very brave and decorated members of my fleet, and things change, shows end, shows start again, and they might be changing ships. So if I wanted to kind of write code to represent that, I might do something like this. So rather than this looking like a function assignment, it almost looks like assign to is an operator, right? And then maybe wharf gets transferred to assign to the defiant. And if I actually try to test that out, you can see that even though we're missing the regular function syntax, they actually work as expected. We can see that we can still run like our contains methods and see that, okay, yeah, they're here and they're not here. And I know this seems kind of silly. This is kind of one of those features that seems like really cool, but you often are not sure where to use it. And I mean, I agree. And I think that, again, this is kind of another one of those questions that I've asked myself is, what is idiomatic Kotlin? Is just using infix idiomatic, does it make sense? And I mean, I guess it really, like, I think part of it is also just deciding for yourself what works for you. I mean, if we want to compare, doing this infix to, what I had before, where I'm trying to say I'm adding crew members with a plus equals and minus equals, maybe you have different opinions on what is the best representation to you. And I think this, again, goes back to being thoughtful and kind of understanding, not just that we have all these cool toys to play with, but what do they mean? And what do they mean for you, for your team, for the, the software that you're trying to create? And I'm not sure which is more idiomatic or whether either of them are idiomatic, but I think trying to think about things, more from the, okay, readability over conciseness, reuse over expressiveness might help answer these questions. And I think I'm running out of time, but am I running out of time? What time is this session over? Sorry. Got 4 minutes? Okay, cool. And I think that's why I think it's so interesting to look at these things and try to understand what is it, like why would they give us this feature? What is this good for? And again, trying to answer this question yourself. And I think sometimes even now, and I hope I'm not going to get like killed for saying this, but maybe necessarily the right question to ask is not, is this idiomatic? And that is like always going to be the right answer. But what is idiomatic? Why is this idiomatic? And does that fit for what I'm doing? I feel like sometimes people ask me questions and I'm like what should I do here? And I'm like, it depends. And that's always I feel like that's not always a bad answer because, yeah, is this idiomatic? Does this make sense? Really depends on what you're trying to do. What is the business logic? What is the abstraction you're trying to do? And I think that's more important really than trying to define very specifically what's idiomatic and what I should be doing and trying to write really strict rules on it, is just trying to understand. And let's see. I guess just because we have a couple minutes, conventions are everywhere and they're really neat. If you have ever heard of delegated properties, they're a way for you to kind of bypass the automatically generated getter and setter. So whenever you write a class in Kotlin and you use val, you automatically get getters and setters generated for you. But if you have, say, some special logic that you tend to use a lot of different places and you want to make your code a little bit drier, if you're an Android dev, say like something that I know that I've done a ton is to have some kind of property, some kind of flag that says like user can do this or user last did this, and then having that saved to a shared preferences file. You can use delegated properties actually to create kind of a nicer, to kind of reuse some of that logic, use that delegating, saving that property to the shared preferences, or doing your funky logic and actually creating a delegate that you can say, hey, rather than using the automatic get and setter, you do the cool thing. And a really stupid example I have for this is this silly name delegate. I ran out of Star Trek puns and metaphors, so we just went with the silly name. So this is a delegate. So delegates are objects, they're classes. And for this silly example, I have a silly user, and the user has a name. It is initialized to null, but how sad for someone not to have a name. So if that user does not have a name initialized, I'll just pick a random name out of the list and let them use that. But once that user has established their name, I'll go ahead and call the actual name instead. And just to show you how this works, let's see, delegate main. All right, so here's my user. The first couple times that I call this method, the user doesn't have a name yet, so I'm going to pick some random names out of my hat. But once the user is like, no, hold on, my name's Jerry, then that user is now Jerry. And that's all done with delegates. And as you can see here, the way that I use this delegate is to declare that property. And then rather than defining a type and initializer for it, I use this keyword by and then pass it an instance of my delegate. And again, I know I've used this for things like, again, if you're an Android developer, having properties kind of linked directly to shared preferences. If you just have some custom logic that you're just using over and over again, rather than copying and pasting that logic, go ahead and throw that logic in a delegate and then use that delegate in multiple places. There's actually delegates that live in the standard library for kind of common accessor patterns that you can access. So lazy initialization. Another example that has nothing to do with Star Trek, because I just totally ran out. So say that I have this object. It's called a MacGuffin. Getting the MacGuffin requires some weird, complex, and kind of ineffable things. And say that MacGuffin is a property on a briefcase, or it lives in the briefcase. And say like some stuff happens, I get the MacGuffin into the briefcase, and then I try to resolve the plot of my weird movie. If I actually wanted to run it, let's see. And of course I have the main back up there. I'm going to remove it. All right. So I have this object. Say like you have some object that requires some complex, expensive logic to get it going. You'd like very much not to run through that expensive, weird logic if you don't have to. Now, normally, say I had an object like this, my briefcase, and it has this weird, expensive MacGuffin living in it. If I instantiate my briefcase and I run through all this logic, you can see that, okay, as soon as I instantiate that briefcase, that weird expensive logic happens, and then the rest of whatever's happening in my main happens. Now, I really like to avoid using, going through that expensive stuff if I can. Like say, like I had some function that, checks did things happen. If things did actually properly happen, then you can resolve the plot and do the expensive weird thing with the MacGuffin. Now, if I just ran this as is, even with that extra check, I'm still doing that expensive, weird logic because it happens during initialization up here. Now, say I did something like this. So this is lazy. It's a delegate that lives in the standard library. And what lazy does is that it doesn't run the initialization code here in the curly braces until the first time you access that. So if I actually instead do this, and if things didn't happen, which I don't think they did. So see, here's the difference. So before, when the briefcase got instantiated, all that expensive logic happened. But because I used the lazy delegate here, because I didn't actually access that thing, that expensive weird code didn't get run. So again, this is a way of only doing what you need to when you have to. And that's an example of delegates. You can write your own delegates. They're using conventions as well. And yeah, so basically, I guess the idea is that I really like conventions as a concept because I think thinking about how conventions work really teaches you certain things about how, how the people behind Kotlin think, and about what you should be thinking of, and, how that might inform both the code that you write with Kotlin and the code whether the features and utilities and tools that you write with Kotlin. So using the features as is in the Kotlin standard library and the Kotlin language itself, and writing your own stuff. And again, maybe asking what is idiomatic Kotlin is not the right question, but understanding what is right for you probably involves thinking about some of these things as well. So anyway, that's my talk, and thank you so much for sitting around and listening to me talk kind of fast for the last 45 minutes, but thanks.